and final talk of the evening. Shush, you lot noisy, I don't know. All that nut colour beer, what's it doing to you? Very glad to have Evgeny from IT Pro over in Israel come to talk to us, talk to you all this evening. He's going to talk about grids. Take it away, Evgeny.
So as Matt and James, I'm also a consultant, so I also have a beard. I'm consulting with a company called DevOps in Israel, and we kind of fed up with doing DevOps transformations. I guess you know why. And we decided to open up a school to teach the open source tools often used, like Jenkins, here in London. And if you like my talk and you want to bring students or your clients that you don't like to us to talk, please do. Please talk to me. So let's talk about grids. What do I mean when I mean grids? I actually mean compute clusters. And this talk is going to be a little bit introduction, which I guess you already know, but the trends in the latest software architecture changes. Then a little bit about containers, schedulers, and then containers inside of schedulers. So this should be familiar for most of you. The architecture of SaaS applications. Can anybody guess? No? It looks like this. Basically, there's a software, high availability, lots of servers. You provision them using an API. And you have some other services like load balancers and databases and etc. etc. And this is actually rather new because most organizations are still doing hardware HA, which means they buy these beefy hardware devices. And if the hardware doesn't fail, then our servers will continue, right? Other companies like Google, if the hardware fails, they just throw it away because who cares? It just costs too much to replace and fix. And another trend in the latest software architecture changes coming to us during the latest years is microservices, right? Everybody heard about that. So microservices is writing lots and lots of small applications instead of one big, large, monolithic application. And microservices are defined by some smart people as a loosely coupled service-oriented architecture with bounded context, which means loosely coupled, you are not updating all of the services at the same time. If you can do that, great, yay. And if every service has minimal knowledge of its environment other than his own environment, other than his own database or whatever, then you have a microservice architecture, which is, right? We can disagree if you like. So some microservices are application microservices, like the stuff that you actually wrote in your organization, and some services you get maybe from Amazon or you wrote them yourself if you're the wheel inventing type. And then, for example, at Netflix, all of their microservices put on the one graph, and who talks with who, right? All these lines looks a bit like. Now, the problem is, for most applications, and as we said, all these microservices, blah, 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 is one whale is not enough, right? So you need multiple whales. And, oh, I'll get back to that. And you need multiple whales, so you bring in some software that can put boxes on multiple whales. You just tell it, it's called orchestration. You tell it to create many boxes, and it talks to many whales and create many boxes. Now, I had this slide that shows why containers are so sexy today, right? Because basically everybody wants to bring up applications, especially microservices, in like 1 second or less. It doesn't mean you don't need hardware provision before that, maybe bare metal or VMs. That will take time, but you can do that ahead of time and then scale out your containers, etc., etc. Of course, most bigger organizations are not ready for this kind of change their applications will not be working in this kind of way, but it will happen maybe in the future. So, about orchestration. So there were some people, they invented an orchestrator, a tool called Kubernetes, and then other people, well actually it was the opposite, but then other people came and they brought more tools, and then more people came and wrote their own wheels, and everybody has a wheel to orchestrate lots of boxes on the Whales. And then, of course, once you run Docker on your laptop, you know where it runs, you know it's IP because you only have one whale, it's very small, it's on your laptop. In the production system, which somebody is actually using for Docker sometimes, scary thought, you need the boxes to find each other. So you get auto-discovery, and of course that wheel has been invented many times as well during the last couple of years. Docker is only 3 years old. Not containers, but the Docker. Docker as a buzzword, it's only 3 years old. And then, of course, you have all kinds of infrastructure that you need to deploy this on. Maybe it's public cloud, maybe it's private cloud, or whatever. And it becomes a mess, and it's really, really hard. And it has a lot of things that you need to know and to make it operational. So I want to talk about the orchestration layer, the various advantages and disadvantages of different orchestration tools. Let's start with Mesos. So anybody knows how to operate Mesos? Very few people, great. So Mesos is a project which is an Apache top-level project. It has been around for quite a while. It started as an academic paper, and basically what it does, it separates the hardware or the actual the whales, right? It separates them from the applications, from the boxes. So you have whales in one pile, and then the boxes are kind of floating on top. And the company who is currently supporting Mesos is Mesosphere, and they have recently taken lots of money to do interesting stuff. And Mesos works like this. There's three zookeepers, three masters, and then there are various different frameworks, one of which can be a framework that starts Docker containers, and for example, Marathon. And basically you tell the framework, I want more containers. It will talk to the Mesos master core to choose out of the multitude, out of the 1,000 slaves that you have, the 1,000 whales, which whale is most suitable for these boxes, and then Marathon will execute the Docker on these hosts, and you don't know where they will actually execute, and you don't care, okay? And this is what makes it so powerful, is that you don't actually care where it will run. And with that, you can also have a framework that knows how to create more and more Cassandra nodes, more and more Kafka nodes, more and more HDFS nodes, whatever it is that you need provisioned. You basically tell the framework, I need 100 HDFS nodes, and it will provision them. If only it was so simple. So, the famous Docker versus VM slide. This is Docker, and Mesos is basically many hosts, and one Mesos agent on each. And when you tell Mesos, I want to run applications, it will pick hosts almost at random and will run stuff there. There's an article about how Twitter stole the Borg idea from Google. So basically Google has been doing something very similar to this for a long time, and then Twitter came along and said, well, this Mesos thing looks like just like what Google is doing, but they're not revealing their stuff, so we will use that. So Twitter is using Mesos, and recently Google has revealed their thing and called it Kubernetes in open source. So I kind of jumped the slide. Oh, okay. So multiple companies are using Mesos, and actually today I learned that Airbnb has been using Mesos in 2013 for running Hadoop, but the engineers that were doing that left, and the new engineers decided it's a really bad idea, and they threw Mesos out the door. I didn't know that, but in more articles that I read, I actually realized that this is a blog post from 2013, and the newer ones are saying that they are no longer using Mesos. More companies that use Mesos, NVIDIA says, well, you can use Mesos to run all kind of GPU stuff. Microsoft are saying, you know what, basically Mesos is not Linux specific, so there's no reason why you wouldn't run workloads on Windows servers that have the Mesos agent, and Mesos will just decide to run some things on Linux, maybe Docker containers, and the new Docker containers from Windows running in Bash will run on Windows. Yeah. Okay, but Mesos is not actually running containers. It's just an orchestrator. It can run anything. Some other applications have come around to run containers on top of Mesos or on their own. And one of them is Marathon, which is, as I said before, used, I think, by Twitter, and Mesosphere, the company, is supporting this. You tell it which applications you want to run, how many of these you want to run, maybe 1, maybe 10. You define the memory constraint and the CPU constraint, which Mesos will turn into C groups on the servers. Sorry for being very technical, but hopefully there will be time for questions. And what it does? So you can put constraints like CPU and memory, or if you have booked a port to be used by an application, and that port should be available on every host, then you cannot run more than one such application on a host. It has health checks, so we can like ping via TCP and check if that application is still running, or if it died and another one needs to be spawned. You can subscribe to events happening, like more applications coming along, or applications dying, or whatever. It has this graphical UI and metrics and all kinds of stuff. And with all the money Mesosphere got, they probably will write more features. Another system you might want to think about when you're using AWS and you want to run Docker containers on AWS is Elastic Container Service, which, of course, it's not open source. You don't know how it actually runs behind the scenes, but it does something very similar to Marathon. You can actually you can choose the scheduler to use. They have their own scheduler, but you can put in Mesos instead if you're adventurous. And they have their own AWS Docker registry, and they try to be compatible with the way Docker do things, etc., etc. But it kind of ties you down to just use AWS. And Google Kubernetes is another open source project which mostly runs containers. I think it only runs containers. It has its own kind of agents of Kubernetes that you can install, or you can put a Kubernetes framework on top of Mesos if you're feeling adventurous. And Google Cloud has a hosted Kubernetes orchestrator. So basically, it has all the same features. It can self-heal. If a container failed, it can create a new one. It has some sort of service discovery, which basically means you get a special IP that is only available on the Kubernetes network for all the containers that are, I don't know, Nginx web, right? And it will load balance the request to that IP via all of these containers. And it has the coffee pot inside, so if you thought of using Vault and HA proxy and all that nice open source stuff, you don't need to, because they have included it in Kubernetes, so they have secrets and configuration management. Actually, configuration management is interesting. There's several aspects of it. one aspect is, I have my applications, they need to know what is their configuration on boot, maybe, right? That's one. But another thing is config maps, which means I have like 1,000 services like Netflix, and I need to know which version of which service I need to run right now. And they also have that, so they have lots of stuff. Automatic bin packing means they will try to fit as many boxes in as few whales as possible, and all kinds of other nice stuff. And of course, Docker are very competitive, so they created their own orchestrator called Docker Swarm. Basically, it supports the Docker Engine API, so if you can type Docker CLI and talk to the whale and say, I want more containers or whatever, with Swarm, you do the same thing, but it doesn't run on one host, it runs on multiple hosts. All the new features that Docker supports, like run lots and lots of containers on lots and lots of hosts. It was very synthetic, the performance graph they show. And yeah, and again, you can plug in Mesos if you really like, and etc., etc. And the last one is HashiCorp Nomad, which is relatively new. And I just grabbed Seth Vargo, who works at HashiCorp at some conference, so he gave me more features than the other ones. Yeah, so in Mesos, for example, you have to have a Zookeeper cluster, and that's not a nice thing to manage. So HashiCorp goes without a Zookeeper cluster. It just uses console behind the scenes, which is much nicer to operate. It also has health checks like a Marathon. One very interesting thing it can do, it can run not only containers, it can also execute VMs, okay? It's like they're competing against OpenStack. They're saying, well, if you want to run containers, but you also need to run, for example, Windows servers alongside those on your Linux servers, then you can run VMs, which is interesting. And they have several ways to run whales, like a whale that wakes up every hour, for example. In Mesos, you need to have a framework for that, for example, the Chronos framework. And they have the constraints, and the multi-data center means that they don't have a lot of noise over the network when you have two separate data centers which are far away from each other. And of course, it's written in Go, it's one single binary, so the installation is a non-issue, unlike the other frameworks. And what else? It has bin packing, and it also can orchestrate tasks on existing Windows servers. So it's a really interesting tool to evaluate if you're going this path of having an orchestrator. It is a bit early to have this because all of these are still quite immature, even though some companies claim they are production ready. Yeah, so this is, for example, a Hadoop cluster running on Raspberry Pis. If you have something like this, maybe you want to install it on Mesos or Nomad or whatever. And this is another Google data center. And this is actually, how's that called? That first cluster? Beowulf. That's Beowulf in some university running on very old boxes of metal, which I don't know what these are anymore. And that's it. Thank you. And if I have time and you have questions, and if you want to join into the conversation, blah blah blah, there's a Facebook group which I post all the news coming from the future regularly. You're invited.
Facebook is easy.
Thank you.
Excellent. Anyone got a question for Evgeny? Or does everyone just want some pizza? Okay, big round of applause to Evgeny. Thank you. to do. Guys, can you still be quiet, please? I'm not quite finished yet. Can we have all our speakers up here, please? Still here, Tom? James? Tom's here. James, where are you? Mr. Betterley, you're in the house.
He might have left at the
Here he is. No, he's here. So just a quick wrap up. I just want to say thanks to everyone for coming, even those of you who are talking now. We've had a great event tonight, I think, 3 great speakers. We do give our speakers a little memento of their time with us, just to say thank you. It's a lot of effort to make a presentation and come up here and stand up here and be ridiculed or not. And I should have organised these in advance, sorry. But yes, we have a little memento for all of our speakers. So let's just go through them all one more time. Thank you to Tom Clark from ITV. Which is the next one? These are actually personalised, which is why I'm so careful. If I see these on eBay tomorrow, I'll be very upset. The next one, this one's for Evgeny. And finally, for the guy from the second best DevOps consultancy, it's James Bedley. Thank you.
And
well, thanks to everyone here for coming. The pieces are here. Here comes Jack with my portion. Look, fantastic. Thanks everyone. We're back in about 3 weeks' time over at Just Eat. So yeah, that should be a good event. Thanks everyone for coming. Can you please put all those bottles in the recycling, please, so we don't get into any more trouble. Thanks everyone. Good night.